Hi everyone, it's the professor. Let's continue our topic of LCM, and today we will look at another variety of LCM application question. So in this question, it's pretty similar to the previous question that we discussed. However, there is a key difference that in our last example, we had the same remainder in each case. However, in this case, when a least three-digit number is divided by 12, 24 and 28, leaves the remainder of 10, 22 and 26 respectively. That means in this case the remainders are different in each of the cases. However, in our last example we had the same remainders. So let's try to understand how do we approach such type of questions and what is the key to look forward to approach this type of question. So beginning with the question in the same way, let's assume this three-digit number to be x. Okay, let's assume this number to be x. Okay, so we have x as this number. Now when I divide this x by 12, x when divided by 12, I'll get some quotient as a and my remainder would be 10. Okay, when this x is divided by 24, I get b as my quotient and the remainder is 22. And when I divide this x by 28, I get a quotient as c and the remainder is 26. Okay, so if I write it down algebraically, I can write x as 12a plus 10, x is equals to 24b plus 22, x can also be written as 28c plus 26. Now we have this algebraic equation in which these remainders are not same. In our earlier example, these remainders were same, so it was easy to take them on the left side and then equating them and taking out the LCM. However, in this case, these remainders are different. So let's try to understand what we can do. Let's add a 2 on both sides. Okay, so I'll add 2 here and I'll add 2 over here. Same with this, same with this, same with this also. I'll help you understand why did we add this 2 in the latter part of the video. So if I just add this 2 in the first equation, I'll get x plus 2 is equals to 12a plus 12, x plus 2, the second equation would be 24b plus 24, x plus 2, 28c plus 28. Okay, so in this case I see a 12 as common, in this one I see 24 as common, and in this case 28 as common. So let's take it out. So if I write it as x plus 2 is equals to 12, a plus 1, then I have x plus 2 is equals to 24, b plus 1, then I have x plus 2, 28, c plus 1. Now that I have reached this portion, I can see that I have x plus 2 on the left side, that is same for each of the equations. On the right hand side, it's a multiplication of 12 into something, 24 into something and 28 into something. So x plus 2 necessarily has to be a common multiple of 12, 24 and 28 because these are in product. This is also in product and this is also in product, and all of these three are individually equal to x plus 2. So x plus 2 necessarily is a LCM of 12, 24 and 28. So if I just calculate the LCM of 12, 24 and 28 using the assumption method, in this case I can take 24 as my number because I have two numbers which are of the same category per se. So if I take 24, 24 is already a multiple of 12, so I needn't worry about this. I just need to check about this. So 28 is made of a 4 and a 7, and 4 is already a factor of 24, so I just need to multiply that 7 to 24, and that would be my common multiple or the least common multiple also. So 24 into 7, which would be 14, and 168. Yeah, so 168 is my LCM. However, this LCM is of x plus 2, but I have assumed that three-digit number to be x, so I need to check upon what is x. So I have to deduct 2 from this. So x would be 168 minus 2. X is to be 166. I'm sorry, 166. So that is my answer. 166 is the least three-digit number that when divided by 12, 24 or 28 leaves a remainder of 10, 22 and 26 respectively. Now to understand why did we add this 2 on both sides in the first place is because if I just see that the remainders have something in common. when the number is divided by 12, I get a remainder of 10. That is just 2 less than 12. If it is divided by 24, I get a remainder of 22. Again, it's 2 less than 24. When it is divided by 28, again 2 less than 28 is the remainder. So every time this difference, 12 minus 10 is 2. 24 minus 22 is again 2. 28 minus 26 is also 2. So this is something known as a negative remainder. We will be studying this in detail when we'll cover the topic of remainders in our coming lectures. So when I normally say that the remainder is 10, 22 or 26, that means I am talking about the positive remainders. 2 in this case is the negative remainder, because the remainder is every time minus 2. Correct? It is 10, that is 12 minus 10 is 2. 22, 24 minus 22 is also 2. 28 minus 26 is also 2. So this is the negative remainder, if I would say. So the negative remainder is always 2. That was the reason why I added 2 on both sides. So these are the two main broad type of questions that come out of LCM. In one case the remainders are same, in another case the remainders are different, but these remainders are only positive remainders. The negative remainders are same in this case. So we need to understand whether we are talking about negative remainders being same or the positive remainders being same. And also, as we learned the general form of a question which has same remainders, we can also understand the general form of such questions also. So if I had the question, find the least 3-digit number that when divided by, let's take 10, 12 and 15 leaves remainder, I can take 8, 10, 13 respectively. Okay, so in this case again the negative remainder is 2. Right, 10 minus 8 is 2, 12 minus 10 is 2, 15 minus 13 is again 2. So the negative remainder is 2, which is same in all the cases. So just to understand what we are actually doing, we are just calculating the LCM of these numbers. LCM of 10, 12, 15, that would be the LCM, and we'll subtract this negative remainder, because it's a negative remainder, so we need to subtract it. So that means I'll subtract it 2. So this is the general form of such a question. So just to understand, the LCM of 10, 12 and 15 is 60. I hope you are very comfortable with that number also, because 10, 12 and 15 is something you will often see when you are doing questions on time and work also. So with the LCM coming out to be 60, I'll deduct it 2. That means it is 58. However, this is not my answer, because I am talking about least 3-digit number, and 60 is nowhere near to a 3-digit number. So firstly I have to get to a 3-digit number, and then only I can do this addition or subtraction. So if I just write it down in a more precise way, I can say LCM of 10, 12 and 15 multiplied with a constant k such that it leaves me to the given condition, whether it's the least 3-digit or highest 3-digit and so on and so forth. So I will multiply that with a k and then I'll subtract it 2. So this is not my answer. 60, if I put k as 1, that would give me 58, which is not my answer. So 60 into 2 minus 2, which would give me 120 minus 2, so it would be 118. That is my correct answer in this case. So it becomes really important to keep in mind that you need to multiply this constant so that your given condition is met at the end. With that thought, I'll wind up this video lecture. We'll cover some more application questions in our coming lectures. Thank you for watching. Keep studying. Stay safe. It's the professor. See you. Bye-bye.